So let's take a look at these two rooms. And in this case, we have our air handling unit represented by these dashed lines here. And there are a few temperatures that are shown on here. I've got my outdoor air coming in. I've got my return air coming through this stream. But again, we've got two VAV boxes, and we're taking 55-degree air and bringing it to the inlet to the VAV box. All right, that variable air volume box. We have two people in here, and oh, by the way, we've got this beautiful south-facing window. Guess what we have there, unless we have blinds, and even if we have blinds or some form of glazing, it might be automated glazing where you send that little electrical pulse to change the transparency of that window. There's going to be a lot of heat right there. And oh, by the way, rather than just doing the lighting above, what if we have an incandescent bulb in this task lighting over here? Your plug loads, as they're known, increase the amount of cooling that may be necessary. So in this case, we have a larger shared office. We have the solar load that's increasing the need for cooling. We have two people in there, two people breathing, two people creating bioeffluents, et cetera, right? Their body temperature, the moisture coming off of them will increase the temperature and the humidity in the space. And what we're doing is this air handler, they control to supply temperature in the VAV air system. So supply as in how much, what is the temperature of the air that I'm sending down that ductwork that then can be distributed in my facility. So in this case, we are going through the VAV box. They need a lot of cooling. And so their damper, their valve, their air valve is 100% open in this case. This guy over here, I just have one person. She's in a dress. She doesn't have any windows. I hate when I'm in offices like that, right? She doesn't have task lighting. She needs less air, typically, than these other two in that shared office with that extra load. They're on that exterior wall versus an interior wall. Different heating and cooling requirements when you're on an interior space versus you're in a perimeter space of your building, right? And so her load is more moderate. So what's going to happen is that damper, that air valve, is going to back off a little bit. And there are different styles of it. And some of them pay attention to how much air is moving through them. Others just by proxy estimate, right? Because they've done testing for their device, for their VAV, variable air volume box. They've got to feel there's a curve associated with that damper position. Others actually have what's known as an airflow measurement ring on the outlet. So you can actually say this many CFM or cubic feet per minute, the measure of air volume being delivered. That will give us feedback into the system to make sure that we're having the right amount of airflow into those spaces. And oh, by the way, what happens if this damper starts closing off and this damper is closing off? And let's say these are closed over here. Maybe they're gone for the day, so they don't need any airflow, or maybe just a very minimal airflow. You do not want this supply fan to deliver a constant volume as a non-varying volume CFM of air to go down that ductwork. Bad things can happen to the system. There's only so much flexibility that you have. So we need to be able to modulate